The graph above shows the base of an object. We're going to compute the exact value of the volume of the object, given that the cross sections are perpendicular to the x-axis, and the cross sections are going to be isosceles right triangles, and the hypotenuse is going to be on the base. So I've taken a couple pictures here so you can visualize what this is going to look like three-dimensionally. The problem is telling us that the cross sections are going to be isosceles right triangles. And so when we look at this picture, we're going to have it three-dimensional. It's going to come up out of the space. And I'm going to draw this with a pink line. So this edge here of the triangle is going to touch and be the base for the line across the x-axis, perpendicular to the x-axis. So it's going to pop out of the page. And if you imagine we have an infinite number of these cross sections in here, and we use integration to find that whole volume. So we're just layering all these slices together really close, creating this volume. Now, in order to find the volume, we need to write this in two parts because we have this figure, this base is in two different shapes. We have this piece here that I just highlighted in purple, and then we have this piece here that I just highlighted in orange. So we have to do this on two intervals. The first interval is going to be from 0 to 1, and we got to find the area of the cross section and integrate. Then we have to do the same thing from the interval 1 to 2 and write the area of that cross section. So actually I'll call this cross section 1 and cross section 2 so we don't get them confused. Now, if you look at the picture of the cross section, imagine it doesn't look like it because I'm a horrible artist, but this is a 90-degree angle because it says that the hypotenuse is laying on the base. So this part right here that I just made thicker is going to be the part of the triangle. The hypotenuse is going to touch along the base on this graph. So we need to determine what this triangle is. We need to find the height and the base so that we can find that area of the cross section to do our first interval. So this is our first cross section. So I'm going to call this S and this S for sides. And because it says it's an isosceles right triangle, I know those sides are going to be the same. And then this is the hypotenuse down here that's going to touch the base on the graph. Now, if you notice, when you look at the base on the graph, I'll do this in green. I have this piece that comes up this way. So the height of this line is going to tell me how far out I come in one direction, and then I double it to go in the other direction. And this line, if you look at it, is the line 5x. So whatever value x is, I come out to that value, I multiply it by 5 and go up, and then that gives me the length from the x-axis up, and then I double that to get the lower part. So the whole base is going to be 10x. Half the base will be 5x. Now, using Pythagorean theorem, we can figure out what the sides are, what those values of s are, because we can say, using Pythagorean theorem, s squared plus s squared is equal to 10x squared. Because remember, those sides are the legs, and then the 10x is the hypotenuse. So that gives us 2s squared is equal to 100x squared. And when I solve this for x, and I keep going, you're going to find that s is going to be the square root of 50x. So that's going to be this side here. Now we can find the height of the triangle so that we can find the area of the cross section using just half of this triangle here that I just highlighted in purple. So now we have this picture where I have 5x here. This is a right triangle, and I know that this is the square root of 50x, and I want to find the height. So again, using Pythagorean theorem, I could say that h squared plus 5x squared is equal to the square root of 50x squared. When I solve that for h, you should get that h is 5x. So I know that my height here is also 5x. So now I have the area of my first cross section. So the area of my first cross section, that's the area of a triangle, which is 1/2, the base, which is 10x, times the height, which is 5x, and then we have dx. Now I got to find the cross section of the second part of that volume, which is the part that I highlighted in orange. So for the cross section that's on the orange portion, the base is not going to change. If you notice, no matter where you are on that rectangle of the base of the triangle of the cross section is going to be 10, because you come out 5 in one direction, 5 in the other direction, for a total of 10. Using the same exact procedure, you're going to find that this side here is the square root of 50, and that the height is going to be 5. Using the same procedure. So for the second cross section, you're going to have the integral from 1 to 2. The area of the cross section for the second part is 1/2 times the base times the height dx. Now, when I find the answer to this integral, you're going to find that you get 25/3. When you find the answer to this integral, you're going to find that you get 25. And because the question specifically said to leave it as exact, if I add these fractions, I'm going to make this a 75/3, which is still equivalent to 25. I'm just writing it with a common denominator. I'm going to get 100/3 as my final answer. So that's going to be the volume of the solid that has this base shown in the graph, but then you have the triangle cross sections that come up out of the page.